All right, welcome to this session. This is best practices for building web apps that visualize large data sets. And Jeremy Bartley and Christian Eknes also contributed to this presentation. You'll be at the question and answer. Let's go ahead and get started. Okay, in this session, we'll cover some initial considerations. What the JavaScript API and the ArcGIS platform do for you, how you can optimize your apps and data for better performance by choosing the right layer type, looking at the different visualization techniques that we have to offer, and we'll look at an advanced case on data prep and pre-processing of very large data sets. Considerations before you start. You really want to know your audience. Are you building an application or a map that's going to very interested parties, specialized users? They're likely going to wait, and they're going to be patient for data to be loaded. But if your goal is to communicate information to the general public, and then you really don't know if they're going to be looking at the map that you create on a phone or on a desktop, then you really should simplify the map and really try to optimize the performance. So are you targeting just a few specialized users? Are you building an app for the public? Does the app have the potential to go viral, or the map? The devices question is very important today. You know, most of the general public is going to view the map on their phone or on a tablet. Phones and tablets are great, but they don't have as much processing power as a desktop machine. So you really, in a lot of cases, will have less powerful machines consuming your map, especially for information that goes to the public. Now you're building a map that, like I said before, that you're going to share to interested parties who are going to view it for their work on their desktop. They're usually going to be on a desktop and usually going to be fairly powerful. And then you need to think about the generalization. Choose an appropriate geometry type for the scale that you're looking at. Try to reduce those number of features, reduce the overall vertices. A lot of this happens for you behind the scenes. Let's drill into some of that. First off is that feature layers are really your simplest bet. And we'll talk more about that in a minute. But the one I want to talk to you now about why that's a good option. Feature layers are powered by dynamic feature tiles. This is an efficient, flexible, and scalable way to bring data to the client. So here we've got a map of nearly 1 million building footprints, and these are all drawn in on a web application. And how do we query all that data? Well, we query for it one tile at a time. What's important to note is that the JavaScript API is going to query the data in predictable ways. So it's going to query based on an envelope that's going to be the same no matter what user is looking at the app and what device that it is. That allows caching to take place further down the stack, which we'll talk about in a second. JavaScript API is also smart to only request the fields that it needs. So in this case, it's going to request the object ID field because that's the unique identifier, and the construction year because that's what's being rendered. JavaScript API also quantizes your data. So we'd like to be able to have no more than one vertex per pixel on the screen. So in this case, we're quantizing the data set down to 38.2 meters. We're also giving the server a hint that this is a tiled request and it's okay to start caching it. There's a lot of goodness that you see on the responses. Just to call out a few of those. One is that the data is, I should step back for just a second. We're also requesting the data in protocol buffer format. So this is a binary format that really optimizes the size of the data and brings the data in so that it can be accessed efficiently on the client. So there's good things. You'll see a lot of good things if you were to look at the network tab of your hosted feature services in ArcGIS Online. One is that everything is over HTTP2. Everything is over HTTPS. The sizes are fairly small on a per query basis. These times are excellent. And we see that we're actually getting hits from CloudFront, so hit from the CDN. And it's also being cached within ArcGIS Online itself. So if the CDN ever does not have the latest version, it gets cached there too. And this data structure that comes back is highly efficient. We've been working on this for many years, and this is the most compact way to represent feature geometry. Just to call a little bit of attention here to give you a look under the hood. When we quantize that data, we're turning in the floating precision into integers. So we've got some quantization information here about what's the scale and what's the origin of the transformation. And then we've got the first point in integer space, and then offsets from each point thereafter. So this takes what would be usually a very large, precise number, upwards of 15 digits and per coordinate, per x and y, and reduces it into a very small, tiny, compact integer. The JavaScript API is also efficiently going to process and prepare those features to be drawn on the graphics card. We've done a lot of work behind the scenes to optimize how lines are done so that we balance the display quality with the overall performance. So if we think that it's not going to be noticeable, even though we have a very flexible symbol specification to allow you to pick different types of joins, these joins can be more expensive. If the thickness of the line is small enough, you really can't tell the difference between a quad join or any of the other join types. And there's an advantage to doing that. The processing time is much smaller for a join like this versus these more sophisticated joins. So that's all happening under the hood. And you see a lot of great performance increases in the JavaScript API if you've been following along for the last couple of years. What we're looking at here are building footprints in Los Angeles. And what we have on the right is what came out last fall. And what we have on the left was what was there before that. This is about, I think, 500,000 building footprints, something like that. And you see how fast that data is paged in on a per tile basis on the right. Now, you want to use you have different types of layers available to you. And the most important part is to use the right layer for the job. Let's spend just a little bit of time talking about each of these layer types. Feature layer, in almost all cases, is the best layer for you to use. It's built on the notion of shareable queries across users and across apps. So the JavaScript API will take care of that for you when using the feature layer for visualization. It will send the same request no matter where you are. And that allows ArcGIS Online to cache things at CDN if it's public, and also caching things within ArcGIS Online itself to avoid having to do expensive database calls. That all happens behind the scenes. You don't even really know that it's happening. What you do notice is that the first time you visit a layer, that performance is going to get better as the layer is used. And it's little to no effort to manage these types of layers. Works great for interactive apps. I'm going to take a pause here a second before talking about the other types of layers, and let's look at an example. So here we've got Vancouver building footprints. If we look at this, I got 124,000 building footprints. Notice there's lots of attributes involved here. What I'd like to show you first is a comparison between the classic map viewer and the new map viewer. So first, let's get down and take a look at this. I'm going to go ahead and drop this network tab at the bottom. I've got it filtering out to just show me feature service responses. And let's turn this on. So we'll see a bunch of queries are happening. And 32 queries happened just by me checking that box. The time's actually, it's fairly fast, but that was 13.1 megabytes of data that was transferred. So quite a bit of data for those 120,000 responses. If we look at this, let's pop this up a second. What we'll see is that a couple things. If you were to look at the network tab, this feature tiles compress is true. That means this is cached within ArcGIS Online. And the times overall are pretty good. We're looking at, even though these are fairly large responses, we're seeing times of around half a second. And if we look at it, an individual request, what's in green out of that half second or so, the green is how long it took the server to respond to this request. So it took 156 milliseconds to respond to this query request. And it took 300 milliseconds to download that data. A couple other things to call out is the 3x API would request data, request everything by default. So it would request star for outfields. That means you're getting a lot of attribute data. You're getting all the attribute data, even though you may not use it. Okay, so let's compare this with the new map viewer. Let me turn on developer tools, and I'm going to turn on this feature layer right here. Wow, that was quite a bit faster, and it was less than a megabyte of data transferred. If we look at some of these requests here, you're going to see that it's all coming from feature tiles. We're not getting the benefit of the CDN because I forgot to say this. This layer is private. It's only accessible to me. So we don't use the CDN when the data is private. And what we see here is that I see relative much smaller sizes, actually. If I can pop back here. It's quite easy to see sizes of like 450 or so kilobytes. Now we're looking at about 45 kilobytes. And the main reason that is, because both are using protocol buffer format, the main reason is down here in terms of fields. In this case, we're only requesting the FID field. That's the object ID field in this case. We're not requesting any of the other attributes because I'm not using it. Now, what happens if your app needs to request that data in the future, like you might need an attribute for a pop-up? It all comes in dynamically. So that's all taken care of under the hood. Okay. Now, let's explain a little more about what we mean about feature tiles and what's happening under the hood. So I'm going to go back to my table here. And this is the raw data. We see that it was last updated on February 19th. Let's make an edit to one of these. And I'll just change it back because I don't really want to mess with this data. Keep it correct. But I really just wanted to trigger a data update. So now the data has been updated as of February 21st at this time. If I go back to this, and let's reload this. Now let's turn that feature layer on. What you're going to see is that it's going to load slower. And that's because that feature tile had been invalidated because I made an edit to the data. And see that it's almost loaded all that data. Still the same amount of size, 964, but these query times are much, much longer. See, we're seeing query times upwards of 3 seconds. Now, if I look at these requests, it's all happening on the server. So that this particular query took 6.5 seconds. And the time to first byte, that means the time that's running on the server, was almost the entire amount. 6.48 seconds, and the download time was only 52 milliseconds. So that's what happens when you're going straight to the database and you're not able to leverage the power of those feature tiles. Now, what happens if we reload this and load it again? What you're going to see is that this loads much, much faster. See, all of those feature tiles come back as true. That means it's cached it within ArcGIS Online, and it can return that back to me in a much, much faster time. And we see that the time here is much less on the waiting on the server. Whereas we were seeing 6 seconds before, 5 seconds, now we're seeing 300 milliseconds. It's the power that's happening. Now let's take it one more step forward, further. Let's go back and share this data set to the public. Something I want to call your attention to. It's always important to think about this. Hey, on editing, don't do it unless you really want to edit your data. Keep it non-editable, because when you turn editing on, you lose a lot of the benefits of feature tiles. Things are slower. You lose the ability to quantize the data. It's really important for you to only make layers editable when you have a very specific data collection purpose. Doesn't mean you can't update the data like I just did, but it's definitely important something to watch. Now, the next thing I want to call your attention to is cache control. So when a layer is shared to the public, we leverage the power of a content delivery network, and by default, it's up to 30 seconds. That means once it's cached at the CDN, it won't even go back to ArcGIS Online for 30 seconds. And you can set this as high as an hour. If you're updating your data every 15 minutes, I would set this to 15 minutes and let it be 15 to 20 minute delay on getting the latest updates. It's just a good practice to do. For this demo, I'll just leave it at 30 seconds. Now let's go back, reload this guy. Now what we're going to see is the query times are going to be similar to what we saw before, because feature tile cache still comes into play. But, and I still see the miss from CloudFront, that's our CDN. Let's do it one more time. Okay, now see all those hits from CloudFront? And things even loaded faster than they did before. And what's important is now look at these times. These times are now sub 50 milliseconds. We see the response is that I've got a public cache control set, and it's set to 30 seconds. And I see that I get a hit from CloudFront. And what that means is now the time that you're waiting for that data has been greatly, greatly diminished. We're looking at, 30 milliseconds to get 53 kilobytes of data. And instead of the time to first byte being in the 300 millisecond range, when it's at the CDN, because CDN is globally distributed, you're going to go to the closest CDN endpoint. In this case, I only had to wait 17 milliseconds to get my first data set, to get my first byte from the CDN, and then I downloaded the whole thing in 5 milliseconds. Those are amazing times. That's exciting. Okay, so that's going on under the hood. Let's switch back to the presentation. So feature layers are really great. They're dynamic. They have all the data. If you're building a JavaScript API application, feature layers are amazing because you can do all these dynamic queries against those feature layers. Everything is drawn on the user's machine. It's not a pre-generated tile. It's great for interactive applications. It's just a great option. Next up is raster tiled layers. You can pre-generate raster tiles of the data. That is really going to be your best performance raster tiles because on the client, they don't have to do any work to display a raster image. It's essentially an image that just gets drawn on the graphics card versus a feature layer or a vector tile layer whose needs to be processed once that raw data is delivered to the browser. It needs to be processed in memory and then turned into textures that are drawn on the graphics card. So raster tiled layers are going to be your best bet if people have very slow computers, very slow devices. If you're really concerned about the smallest amount of data download and the best possible performance across any device or computer, I think raster tile layers may be that. Although with feature layers, it's going to be hard to get much better than that 30 milliseconds that we were seeing there. Within the ArcGIS stack, you can still do pop-ups and legends off of raster tiled layers. And probably the biggest thing is that with raster tiled layers, visualization cannot be controlled after it's built. So that means if you rotate the map, labels are going to be fixed, kind of burnt into the image. You can't do any kind of dynamic applications with it or explore that data. Next up is vector tiled layer. And with vector tiled layer, you can pre-generate vector tiles in ArcGIS Online. I forgot to say, with a feature layer in ArcGIS Online, you can build raster tiled layers or vector tiled layers. Vector tiled layers are very similar are similar in some ways to feature layers and raster tile layers. They are pre-generated tiles, but they're not images. They're actually data. So they have that same kind of data response that the feature layer does. The data gets chopped up quite a bit, though. So at the tile boundaries, if a geometry passes that boundary, it's going to be chopped right there. And so you might end up with lots of different graphics that represent an individual feature. And vector tiles include whatever geometry plus whatever attributes you decide to build them with. The benefit of vector tile layers is that they're very dynamic. So just like with feature layers, if you were to rotate the map, you would see the labels rotate. They do allow some level of control over the visualization of the style. That's why you generally see base maps being generated with vector tiles that allows to give very crisp visual quality, and it allows lots of different base maps to be created off of the data in an individual tile. So like for ArcGIS Online base maps, for instance, the Esri base maps are, there's one set of tiled data with many different visualization styles. A downside when you're talking about operational data is that you don't have the ability to work with a legend. You'd have to make your own legend using a graphics package and no pop-ups as of right now. I think most important thing to get out of this session is that feature layer is really the best all-around layer type for you. It's the simplest. Performance is great. It allows you to be dynamic. If you're building an application, you can do so many things on the client with the feature layer. And you can get very good performance through feature tiles. And one other point to call out that at 10.9, feature tiles are coming to Enterprise. And so a portal-hosted feature service at 10.9 will have the ability to do those same feature tiles. So you can get that same benefit on Enterprise, which again on the web. Okay. Now let's talk a little bit about different visualization techniques. One is a pretty simple, obvious one that probably most of you already know, and that's scale-dependent filtering. And for this, we're going to look at this water distribution pipe example. So these are water pipes in the Thailand area. There's over 500,000 features. And if you were to load this feature layer and draw all the features, you'd be looking at, almost 20 megabytes of data that would have to be downloaded. If you filter it, so like say the pipe size must be greater than 150, that's going to drop quite a bit. And if you filter it even more aggressive, like pipe size must be greater than 300, that's going to drop about 6 megabytes off and improve the time. It's important to know you're still downloading over 107,000 features. So it's pretty awesome. Now let's take a look at some examples here. You can before we look at the examples, you can get even more aggressive with this data set. So for instance, if view resolution times 2, setting that pipe filter to be even higher, you're going to get even less features downloaded. And the visual starts to degrade a little bit as if you were to go all the way to here, but you can get kind of a pretty good idea. So all of this really is just doing good cartographic defaults. So if we look at this map here, I've gone ahead and done a little bit of authoring on it. Let me just pop the legend open for a second. We're looking at different types of pipes based on their material and the pipe size. Now, if I look at this small scale view, I'll see that I've got a filter here, and I'm only showing things that are 300 and above in terms of size. So I've selected 300, 400, 315, 350, and so on. I've also set a scale range so that at these scales, I'll be drawing these features. Now, this is still quite a few features, so let's actually look at the table. That's still 107,000 features that are being drawn, so quite a bit of data being downloaded. Now, as I zoom in, things get crisped up. The geometries start to get drawn in a little more detail. I see that data coming in. And do one more. Now I've switched to my large scale layer where I don't have any filters applied at all. And so now we see the full density of this data set. And really from a visualization perspective, even this is probably too much. It depends on what you're trying to show, of course. But there's quite a bit of information going on here. So you could even probably go a little bit more aggressive and not turn all of the features on until you got to even the next level of detail. We'll see that pipe scale has been set. The large scale view, is going to show from the town scale level all the way to the room. And you're going to get good performance, all the way down with this view. Just keep zooming out a little bit farther. Yeah, now I've switched to that other view, and I get kind of an overview of the data set. Now, obviously you can draw more. So let me turn this guy off and turn this one on. This is all of the pipes without any filter being set. So it's drawing all of them. It's just drawing all the same way. It does benefit from all of that feature tile work that I talked about before. But I just, while we're here, wanted to call out what do I mean by feature layers are really dynamic? Well, it's just very dynamic. So if I come over here and let's put pipe size back on again, and let's do includes, and only look at the ones where it's 300, you'll see as the attribute data gets requested in for pipe size, because I remember what I said, the feature layer is smart and only requests the data that's needed. Now that I've applied this filter on the client side, it's gone ahead and requested all that data, and then look, we've got it. Now it'll be really quite fast. So I'm turn on the 400, the 200, the 250, 315, 350. You see what I mean? Very dynamic, very fast. That's what you get when you're working with a feature layer. You have fast access to the data in the browser on the client side, so you can do some pretty amazing things with it. Okay, let's pop back over presentation here. And let's talk about some other visualization techniques, like clustering. Okay, now from a performance perspective, this is, let's see, how many points? These are Chicago home sales, and there's 84,000 points. So, you know, feature layer can work pretty well with this data set. Let's just reload so we can see how fast that loads. Boom, all the data is there, all 80,000 points. But let's spend a little bit of time on this visualization style. What are we really trying to show here? Let's look at something like, use the filter here, sale price. So these are home sales for 3 years, 2013 to 2016. And let's just do color for a second here. Okay. And I have different themes, so maybe I'm interested in the above and below theme. Okay, the map's getting more interesting. Smart mapping has gone in and sized my dots based on the scale. So as I zoom in, those dots will get bigger. And so you'll be able to see them. And we've colored them based on the sale price with a diverging ramp. Now, that does look like a better map, but I think it's still quite a bit of information is hidden in this. And that's your goal, right? You don't want to just give out raw data. Your goal is to give out useful information. And this is an example of giving out too much raw data and making it difficult to see the larger patterns. But you can use these visual techniques like clustering. Let's turn that on, to cluster that data. And you see how fast that was? That all happened on the client based on those 86,000 points. And I can control the cluster radius, so I can essentially have clusters that represent very large areas, or I can have clusters that represent much smaller areas. And notice how the labels are dynamically being updated as I change this cluster radius. Obviously, as I make the radius lower, those numbers are going to get smaller. So the trick is for your data sets to find the right level of clustering. And we've got some pretty nice tools now. So I can control how the size range. So how do I want the big features to be drawn? And the small features as well. So I can get them to try to neatly fit most of the labels. And you have control over these labels too. So I can go in, and by default, it's labeling based on the count of the clusters. But the map is still showing me sale price. But maybe I want to switch this to be the average sale price. Okay. And it automatically added a K to make that fit better. what's cool is this is just an arcade expression. So if I wanted to add something like a $sign in front of it, I can just do that. Now I got the $sign, but I need to go back and change my size ranges a little. They're a little bit too small. And maybe I want to change my cluster radius to have it fit a little bit better. And the smaller ones just a little bit smaller and make these guys a little bit bigger. Boom. There we go. And these are dynamic, so as I zoom in, clusters are going to be recomputed and I see all that information. So this example is just to really, allow how you can improve the visual experience of your maps by leveraging some of these visualization techniques that reduce the amount of information that's being displayed. And clustering is a great way to do that. Just for reference, if I turn that off, boom, I see all the raw points. And now I see the clustered view. We'll also, later on this year, we'll be delivering out a solution where instead of computing these clusters on the client side, which is what's happening here, so I still have to download those 86,000 features, we'll compute that cluster on the server and then have the client work with the server generated clusters. It won't be as dynamic, but it will allow you to work on extremely large data sets, like in the millions, hundreds of millions of features, but still be able to get a good visual out of it. Okay. Okay, now you also may need to do some data prep and processing so that you can work with different geometry types. That might also lead you to thin the geometries or the attributes out. And I'll just talk about one example and then I'll give you a concrete example that Christian put together last year. So one example that you might think about in terms of data prep is, let's say you were trying to build a map of all of the trees in your city. Now, there can be, hundreds of thousands of trees. And trees don't just, in cities, don't just randomly appear, right? They're purposely planted. So you can use techniques like aggregation. So taking your large numbers of trees and aggregating it into census block boundaries. So instead of having each tree having its own feature, you can have each block have the number of trees, the most common type of tree, maybe the average diameter of the tree at breast height, things like that. That greatly reduces the amount of data that's required to generate that map by aggregation. And it also improves the visual. And so I definitely recommend just thinking about different geospatial analytic techniques that you can do ahead of time to reduce the complexity of your data so that you can visualize it effectively. Let's go into the OneOcean app and talk about some of the data processing that Christian put into this app to build it. So this is the Ecological Marine Units Global Oceans data set. And we'll see here that this is a pretty large data set. This is 4 gigabytes. That's very large. And so you might be thinking, well, heck, if I was even just to download this data set, it would take a long time to get that raw data, even on my computer. But we want to build a web application out of this. We want people to be able to walk up to it and just use it. So the goal is to get the total download as small as possible. And so you need to know your data to do this. This data set has points at every quarter degree of latitude and longitude. And then for each point, it's got up to 100 different depths with different attribute information at each location. So there's up to 102 points of depth from surface down to 5,000 meters. and there are 12 attributes per point. So that's 52 million points. And while you're not going to deliver 52 million points to the browser and view it effectively. So what can we do to get this as small as possible? Step one is to reduce the number of geometries to have just 1 point per location. So we call this flattening the table, pivoting the table, generating a fat table. What we're going to do is to take each one of those depth values for a particular attribute, and we're going to pivot it so that those become now columns in the data. That reduces it to like 677,000 features, and the data is now one row per XY. So an individual row has a single XY, and there's only one XY in the entire data set. And then each attribute, each depth level for each variable is now a column. Now the problem that we have here is that we've got over 1,200 fields. So that's too much. But we'll talk about that in a second. 600,000 is still quite a bit too, 677,000. And so for this global visualization, Christian went a step further and aggregated it from a 1/4 degree to 1/2 degree. That brought it down to 84,711 features. That's easy to work with in the browser. And as you saw, we were just working with about 85,000 points in that Chicago sales example. By reducing you can see the difference between a 1/4 resolution, 1/4 degree resolution, and a 1/2 degree resolution. So the turquoise dots are 1/2 degree, and the yellow dots are 1/4 degree. So that's what we're pulling out. We're pulling out just the 1/4 degree, the 1/2 degree version of this data set to get it to be as small as possible. Still a lot of points. Now we need to reduce the number of columns, thin those attributes out. So for hosted feature services, you can only have around 1,000 fields. There's also the size of the data in each field will contribute to whether or not you can actually have up to 1,024, or it might be smaller. Christian went ahead and processed down this to reduce to about 300 fields. Removed about 300 fields, excuse me. And by deciding which variable he wanted to pick and so on. And what we see here is that I have the velocity value at the 79th depth point. And then I've got the next velocity value at the 80th depth point, and so on. And you'll see this just repeated at all the different depth points. We want to really control the number of fields that we get back and not have any extra, because it's going to be quite a bit of data. So one detail here is that setting out fields to star is much better, because it will make sure that all of your queries are HTTP GETs, so that you can leverage the CDN and your browser cache. But you want to control which fields come back when you specify star. So Christian reused the view capabilities of ArcGIS Online, created a hostess feature view, and picked the fields that he wanted and dropped everything else. Now that's going to result in a data set that only has about 300 fields, and when star is used, you're just going to get all 300 of those fields. Set the CDN to 1 hour, and now there's a manageable data set I can work with in the browser. What you can see is that this is still loading a ton of data. It's loading 280 megabytes of data. This is an example of an app that's not usable for mobile devices. The initial load time is a little bit longer, but people are going to wait because they're interested. So let's take a look actually at this app. And definitely check out this blog post, Mapping Large Data Sets on the Web, that describes the slides that I just went through in written form, and has a link to the app itself. And so this app is really cool. It's very dynamic. See how I'm moving my mouse around, and I see that profile, depth profile on the left. So that's showing me at where my XY is, all of the salinity values at different depths. I can also view this map at different depths. So as I'm moving this down, you see that map is changing. And that's because it's telling it to draw a different attribute. And this is a very fast operation to do in the JavaScript API. And you get very good performance. And I can even switch between different variables like temperature, or show the currents. If I look at this, you'll see that I've got each data point going in the direction of the current, of the main current for this data set, and then colored by its temperature. And this is at different depths too. And you can see interesting patterns that you might not have seen. So yeah, this is a great example of processing the data ahead of time to improve the overall visual. So in conclusion, the ArcGIS platform does a lot behind the scenes to optimize your data and apps when loading large amounts of data, but you can do more to optimize your apps for better performance by looking at different visualization techniques, picking the right layer type for the job, doing some data prep and data processing. And please provide your feedback after we finish out the question and answer, and I think we're up for question and answers. Hello in there. Thanks for watching this session. I'm Jeremy. I'm joined here with Christian. We were unable to socially distance record this session together like we were supposed to, so I ended up doing the whole thing. And but Christian's joined me for the Q&A. And yeah, go ahead, Christian. What do we got?
Yeah, no problem, Jeremy. Thanks for taking over the whole thing. All right, so we got a number of questions. Let's just go ahead and dive in. But before we do so, I just want to point out we're not going to be able to get to all of these questions. So if you put a name in alongside your question, so it's not anonymous, we'll be able to reach out to you and answer it after the session. And if not, you can always go to the Ask Our Experts section in the Dev Summit website there. So just want to point that out. So first off, Jeremy, do these improvements in feature layers and the map viewer performance apply to enterprise or just ArcGIS Online?
That's a great question. It can be confusing for sure. Well, the performance enhancements to the JavaScript API, of course, work for both. How the JavaScript API requests data depends on the capabilities that are there. So the protocol buffer format, that's the binary version of the data. That's been in ArcGIS Online for a while. And it's been in enterprise since, for feature services since 10.7 or 10.7.1. And then map services, the JavaScript API will start consuming protocol buffer format automatically at 10.8.1. What's exciting, what's not been in enterprise is the feature tile support. And that has been an online only feature. And that's, to be honest, that's how online scales to handle, billions of people viewing maps for ArcGIS Online. And that's now available as part of 10.9 for enterprise hosted feature services. And they have plans to support that for other feature service implementations and map service implementations in the future that go directly against your STE database.
Cool. So that actually answered a few questions. All right. It sounds like that I can only get benefits of CDN delivery if I make my feature layer public. Is this the case, or is there a way to get CDN benefits for non-public feature layers?
That's a good question. CDN, in terms of what is cached at the CDN, only comes into play for public content. You know, we don't want to put your private content on a CDN where you don't have control over it. So that's the main reason why. But feature tiles that's the caching that happens within ArcGIS Online, and then of course at Enterprise at 10.9, like I said. And that happens for all types of data, public, private, whatever, it doesn't matter.
Cool. And okay, so I think this was in reference to a poll that we put out, but what about map image layers? There wasn't a lot of discussion about that in this session, Jeremy, so do you want to say something about that? So it seems for large features, you don't get the warning about not all features displaying all features when using a map image layer versus a feature vector layer.
Yeah, good question. Map image layer still has a role in serving out your geographic information. One of the big challenges I would say with map image layer, and this also applies to OGC WMS, is that it is impossible to cache those. So if you think about it, every slight pan of the map on every different device size, computer size, results in a different exported image from the server. So if your goal is to reach, you know, hundreds of thousands of people, or billions of people, or millions of people, you're not going to be able to scale it with map image layers. Now, if you're working in a small work group type setting, where you know it's a small audience and will always be a small audience, then map image layers can be useful. Basically, having the server do all the work. Even in those cases, I would say that you're probably better off with feature layers, unless there's some kind of advanced cartographic technique that you need from the map server that we don't have support in the web yet. And it also, the data changes too much to build a cached version of it. That would be when you want to use map image layers.
All right. For the same source data, scale levels, etc., which takes more storage, raster or vector tiled layer?
Oh, definitely vector. Well, yeah, most likely vector. I guess I shouldn't say definitely. Depends on your image format and how many colors you have and so on. But yes, you know, raster tiles are going to be. I guess actually that's a more nuanced answer, because with vector tiles, especially if you build them in ArcGIS Pro, we build an indexed version of the tiles, so we don't have to build tiles for all scale levels, and we can use the vectors to draw dynamically at the smaller scales, or larger scales, excuse me. So maybe it's not cut and dried answer. But really, I just go back to feature layers versus raster tiles versus vector tiles. The nice thing about feature layers is just you're not building and managing a cache. I mean, if you're using the feature tile capability of Enterprise 10.9, then there's a new data store option that will support that feature tile cache. But for ArcGIS Online, you don't even have to manage that. We just take care of that for you. Yeah, that's probably it. I don't know, Christian, if you want to add anything.
No, I don't have anything to add.
Okay.
And regarding, just wanted to point out, just because there's multiple questions about ArcGIS Enterprise, there was also a session that went at the same time as this one by Philip Heed about, you know, best practices for working with your enterprise layers. If you reach out to him, he also has matrices that he's built out that show version numbers and things like that. So I recommend that as well. Okay. Is there a way to author and publish a referenced feature layer that delivers cache tiles from small scale to medium scale, then from medium scale to large scale, delivers live records from a feature class in a referenced enterprise geodatabase? So the idea is you have, at small scales, you deliver a picture, and then at large scales, it's the raw data values.
Yeah, definitely you can use, you know, scale visibility range on your layers to achieve that. So you can keep let's say you had, you know, billions of features, you could have build raster tiles of that and consume that as images. And then when you get down to a level of detail where it makes sense to pull the feature data through feature layers, you could do that.
Nice. Can raster tile layers be queried?
In the ArcGIS platform, yes, you can. In the context of a web map, you can buddy up a layer in a map service or layer in a feature service and use that to query and power your pop-ups. So yeah.
Cool. Many times when I try to grab a data layer to use in the desktop app, it says that I'm exceeding the maximum number of queries for features. How do I get around this for analysis?
I'm assuming you mean for ArcGIS Online. And I think if that's the case, if you're reaching that limit, then you're better off actually exporting the data out from ArcGIS Online into a local file system and then bringing that in. But probably the best bet would be to go to the showcase, ask an expert question and drill into it and see what on the desktop side why that's happening.
Yeah, I mean, we see these warnings also just in our apps too. So I know Matt George, who's in the expert section on the web development, could help there if that's what you're referring to.
I think in this case, they're looking for desktop issues. So it's probably best to talk to the desktop team. We're constantly changing how we query the data out based on the capabilities of the server. I'm talking about we being the JavaScript API team. And Matt George leads our effort on this in this area. And actually, we've changed how we've queried the data based on the capabilities of the server many times over the last couple of years. So we're constantly trying to make that better, improve the download size and the time it takes to get data from the server.
Cool. Just have a couple more minutes here, but so a couple of people asked about the OneOcean app and the blog. I'm going to post that as an announcement right now. So it should show up at the top of your chat window, that link to that app and blog. So, all right, we have non-spatial data that has more than 8 million records on ArcGIS Online. Had issues downloading the data file via ArcGIS Hub. How to remedy that? I think
I can take this one, Christian.
Go ahead.
Because there's been some enhancements there on the online side. We now, when you export data out of online, we're also using the feature tile capability to basically cache that so that you only pay the cost of actually doing the processing of exporting the data out of that data store into a local file once, and then that's cached. And then until the data is updated, Hub or any app calling export into ArcGIS Online will be pulling directly from that cache. So that you should try that again. The performance should be better.
All right. Okay, this one just got bumped up. What is the best way to optimize the schema of large data sets that need the ability to be time enabled?
Yes, our traditional time based, like if you use the time slider, works on the notion of visibility. So it will download all of the data that it can and then hide or show features based on the time and where the time slider is. What showed in Christian's OneOcean app demo, and what Ann Fitz showed in her plenary demo, where she looked at age pyramids and age population, that took it a different way. That followed that paradigm of taking those features that have a different feature for every row and created one feature out of them and turned them all into columns. So that's another way to work with time.
Yes, and Undrol and myself will be presenting about animated data sets tomorrow. I'm not sure if it's in the morning or afternoon, but sometime in the tomorrow, there's a session about animating data sets. So we address this topic actually there. So you can, I also encourage you to check out that session, and we can also discuss offline or outside of the session there if you have more questions. And
We do
last question.
one more, yeah.
Yeah, last question. So what's your record set quantity thresholds for clustering and other approaches? Does clustering start to drag at 1 million, 5 million, 10 million records?
Yeah, this is a great question, and this is a feature that we're working towards. So our current clustering solution requires all the data be brought to the client, and the clustering happens on the client. Where we want to get to in the next couple of releases is to support working with the server side data stores that create those aggregated bins for us based on the data and have it server side. So, so look for solutions over in the next couple of releases to come out on the JavaScript API side to work with these very large feature services where we're getting the bin data from the feature service and generating the clusters off of those bins instead of getting all of the data. This will allow you to create clusters of billions of points.
All right, we're out of time. Thank you for coming out. And if you have more questions, go to the Ask Our Experts section and ask there. Thank you.
Cool. Thank you.